Well, hello, and you're very welcome to the introductory dissemination session for the Bahrain Green Building Code, which, as some of you may know, first became law in October 2019. I hope you'll find the material clear, and I hope it helps in your understanding of what it is we're trying to achieve, and I guess what you as designers need to do in order to comply with the various requirements of the code. So my name is Patrick Shield, and under the auspices of the original SEU Sustainable Energy Unit and the UNDP, I was involved in the initial efforts during 2018 and 2019 to get the Bahrain Green Building Code initiated and off the ground. As you know, that unit has since become a full authority in its own right, now referred to as the SEA, or Sustainable Energy Authority of Bahrain. As far as my own part is concerned, I'm involved in both research and as a practitioner in the US and Europe, and I maintain a strong interest in building energy efficiency and energy policy in general in both Stanford University in California and Trinity College Dublin in Ireland. So let me explain the structure of the session today. It's organized as a background showing why we are trying to make the necessary changes that are involved here. And I guess out of the main energy sinks throughout the world, industrial, transport and buildings, we're obviously going to focus here on buildings, what we have learned about them and what we can do to improve them. The next section is what Bahrain did in order to respond to that very, very large challenge. And as a result, the Bahrain Green Building Code was created and sections contained will be explained. And finally, the development of the green building rating system itself. So in other words, into the future, we'll be ranking buildings based on their sustainable characteristics. So as a background as to why policymakers may need to intervene in what predominantly has been a free market up until recently, with obviously the exception of some health and safety issues and basic standards. The changes we have witnessed in our world are actually becoming more and more apparent. And in every context, be it the climate, the rising sea levels, the amount of global warming that is occurring, the picture appears to be deteriorating and deteriorating at an ever increasing rate. Sea levels are rising, putting coastal communities at risk, and that in effect may ultimately affect Bahrain more so than the vast majority of other countries. So as a background as to why policymakers may need to intervene in what has predominantly been a free market up until recently, with the exception of some health and safety issues and basic standards of construction, the changes we're witnessing in our world are becoming more and more apparent. And in every context, be it rising sea levels or global warming itself, the picture appears to be deteriorating in every sense. Sea levels rising probably puts coastal communities much more at risk, and that obviously is Bahrain in so many ways. So it has taken many decades to organise ourselves into what could be considered a cohesive block in order to tackle the underlying issues. So if we look at the policy changes and the government efforts over time to control overuse of energy and water, probably starting back in 2079 with the introduction by the Japanese government of their efficiency policy after two major oil crises, the road has been comparatively bumpy, but we have reached an accord in Paris in 2015. The accords that were reached and kind of watered down in Scotland up in Glasgow very recently were not so effective. So let's have a closer look. But Bahrain itself is obviously a signature to that Paris Accord, signed in April 2016. So, but based on the figures in this slide, if we focus specifically upon buildings, so we can see that a very, very substantial amount of the raw materials we have available to us on the entire planet are pretty much used. And almost 40% of the waste that is coming out of the planet is basically from the construction industry. So a very, very large influencer. And as a result, the policymakers have focused very specifically upon this sector. Now, it could actually possibly be argued that the types of buildings we are constructing in climates or in localities where the climate simply does not suit the style of building that's getting constructed, that is probably getting worse. So we can see that in Europe and the US, we can see buildings in terms of their use of energy are accounting for 40% of all energy used. Now, the really worrying thing is that that percentage is actually increasing as well as the overall use of energy figure itself. So it is accounted specifically for the level specifically of AC that is used in buildings throughout the world, and it's only getting larger. And in other words, the problem is only getting worse. Now, if we delve a little further into a building's energy usage in terms of its internal breakdown, so we can see that the usage on HVAC accounts for half of the total in general. The exception, I guess, in this particular slide is the UK, and that is interesting in its own way, given that the main load for buildings is heat, but there's a sizable proportion on AC. Now you'd have to ask yourself the question, why on earth are buildings being ACs or air conditioned in Britain, of all places, given the climate they have? Ireland is an exception as well, as is France and Germany. So in Bahrain, there are estimates from EWA, the Electricity and Water Authority, where they reckon that over 60% of the total HVAC energy is expended upon air conditioning. And I'd have to ask myself the question, do we really need that much air conditioning in Bahrain from, let's say, the end of November until maybe the beginning of April? Are we overusing it, in other words? There has obviously been an awful lot spoken about sustainability, and everywhere you look, everyone is claiming that they have some sort of a sustainable agenda in mind. The best definition I have come across throughout the many years I've been looking at it is simply to say that we are planning on the use of resources at a rate that will meet the needs of the present without impairing or imposing any further restrictions on the ability of future generations to meet their requirements. Okay, and it is a reasonable approach. So all we're saying is to leave the planet as we found it, if not in better shape. Okay, so we certainly do not want to make things worse. The other thing that gets overlooked an awful lot of the time is the fact that there are very many number of benefits that derive from a more sustainable built environment. And in this slide, the IEA, or the International Energy Agency in Paris, you have identified a significant number of very positive attributes that flow simply from more efficient, energy efficient buildings. Some of them not so obvious, but an awful lot of them very much are obvious. The National Energy Efficiency Action Plan, which was derived by the UNDP and also by the Bahrain Economic Development Board, it was adopted by the Bahraini government in 2017, covers a full 22 initiatives spanning 6 major policy areas. So we can clearly see that the widespread nature of this very important development, covering everything from transport to government, utilities, appliances, and of course buildings. So for the purpose of this introduction to the Green Building Code, we can see already identified targeted opportunities for better energy efficiency in this labelling of both commercial and residential buildings, appliances. Like, and these aren't only kitchen appliances, it also covers a lot of plant that will normally be installed in buildings of various sizes, and also, of course, vehicles. But also the application of new technologies such as district cooling and the data collection through smart metering programs. So all of those are covered, and in a lot of ways, the Green Building Code at least touches, if not covers, the vast majority of these important initiatives. So as a means of seeing how one might apply such policy aspirations deriving from the National Energy Efficiency Plan or Action Plan, we started to examine the various application codes or applicable codes from similar climatic regions, such as the Gulf Cooperation Council area. So many green building codes exist across the world, the most familiar to all of us here probably being items like either LEED or BREEAM. And as it happens, Bahrain has several enrolled LEED buildings already. So this is a sample from the other GCC countries with a very, very similar climate in terms of the heat levels and the humidity levels, such as Singapore, for instance. So it is clear that while many of these have been around since 2010 and possibly even before that, they are actively keeping up with the pace of change, and they in essence roll the version numbers, or they update those standards on a regular basis, probably and mainly due to technological advancements. Okay, so the building materials are improving, the efficiency of HVAC equipment, how we heat and cool our buildings, is improving all the time. So it is important that those improvements are being applied to all of those codes in a positive and constructive way. So one would have to ask the question, why would a country develop its own code given there are many available ones out there? And I have to say there are several reasons for that. So we can actually see that in having one's own code, one actually maintains control of the policy levers that cause change within that country. So policy change is easily facilitated. The recognition of national assets is easily included. Promotion of local products and services. The upskilling of local employment and professional bodies is embedded in having one's own code. So in essence, there are a lot of arguments for having one's own code and very few arguments against. So all of these high principles and actions, I suppose, are leading ultimately to the creation of the Bahrain Green Building Code. The code was originally brought forward by municipalities back in the day, 2014-15 and so on, and originally based on the Dubai Al-Safat standard, which still exists and getting updated in Dubai as we speak. So in seeking to ensure that good practice learned in other GCC jurisdictions was to be included, and anything learned obviously would be covered, a full comparison was carried out between 8 of the codes deemed most applicable to Bahrain. So most codes were commenced about 2010 following the Kyoto Accord and the accord that was reached in Bali. So we examined the diversity of each code along with the cost of implementation. Also examined are the administrative and management overhead and practices that are involved in their implementation and maintenance. And we believe that the resulting code is easier and less costly to implement than any of the other neighbouring codes. So all of these codes have this concept of a passing grade or a minimum number of articles implemented to basically earn a level or a basic level of certification. The minimum levels in other applicable codes are substantially higher than the Bahrain Green Building Code. And I guess it would be fair to say that it is in the plan that the Bahrain Green Building Code will eventually have to follow suit. In other words, the passing grade will have to increase as time passes and technology advances. Okay, so it's also arguable that the 10 articles that are now required to achieve basic certification are kind of almost at a very, very easy entry level. They are normally included in the vast majority of buildings anyway, but they are a basic entry mechanism. Now, it's also important to point out that the assessment here under the Green Building Code is an assessment of the as-built building. In other words, it is an assessment of the building as an asset. But given the very high level of energy consumed over the operational lifetime of the building, as opposed to during construction, the operational phase must be assessed also. So it is estimated that about 90% of the energy used during the entire life cycle of a building, from design to demolition, is during its useful or occupied life. The object of the exercise here is to significantly reduce the burden on scarce and expensive resources such as energy and water. Okay, so it is very important that we understand that there is an assessment coming as part of the rating system that examines the building in use or the building during operation. So overviewing the hierarchy of the building permits application and issuance process, we can see that the BENAYAT sits at the top, providing unified guidance on how permits are controlled, issued, and what regulations apply. The Green Building Code itself forms part of BENAYAT, a very small part, I have to say, and the published Green Building Manual, which contains all of the articles of the Green Building Code, is included under the Ministry of Works, Municipalities and Urban Planning sections. The practice guide is a full implementation guide for those wishing to apply the GBC to a building design during construction and mainly during the design phase. It also shows how the ratings themselves are calculated. And finally, the operation of the building is going to be assessed under a rating system also, and that is probably going to be an optional system where people can have their buildings assessed for operational efficiency. And this may be of particular interest to building owners who wish to ensure that the value of their asset is being maintained because it's being operated very efficiently. So I want to make sure here that people understand what's going to happen into the future. So after its introduction in 2019 as law, that Green Building Code, there's an underlying assumption that the minimum standard, just like most other green building codes, the minimum standard or the mandatory articles that apply to a building will absolutely expand in number over time. As mentioned before, this is primarily due to technological advancement, but also policy shifts or policy changes at government level where government may wish to encourage certain industries and so on. Okay, so how buildings are rated and the system governing such ratings that will be included in the rating system to follow on from our introduction of the Green Building Code. The implementation and enforcement of the mandatory articles outlined in the Green Building Code is completely independent of the rating system, and it's completely independent of any international rating system. So just because you have got a LEED Gold building doesn't necessarily mean that you automatically pass the minimum standard of certification within Bahrain. The following list explains the buildings to which the Bahrain Green Building Code currently applies. We've explored the applicability of each article on an article by article basis, but generally there are 5 building types considered, as you can see: villas, residential buildings, commercial buildings, including those listed there in number 3, public buildings as listed, and finally industrial installations. With those 5 building types, the scheduled application of the Green Building Code, or when it applies, is indicated here. This is already published as part of the ministerial order introducing the law back in 2019. So we can see that all government public buildings and commercial buildings over 500 square meters are already included. So as in from November this year, pretty much all buildings are covered. Now, in terms of structure, the Green Building Code itself consists of slightly over 100 articles, of which 79 of them specifically apply to buildings of various kinds, be they commercial, residential, industrial, or government buildings. The vast majority of those 79 articles are simply aspirational things that hopefully designers have included in the design of the building, and that they will be scored as part of the rating system at a later point. But for now, of those 79 articles, there are 10 that are included as mandatory items. Okay, so these are articles that have to be complied with in order for municipalities to issue a building permit. Okay, there simply is no way around them. The vast majority, as I mentioned earlier, of these 10 are already included in the vast majority of buildings already being designed and have been designed within Bahrain. There are a few new items, and I specifically draw your attention to Articles 56, 65, 75, and 76, and of course 77. So these are specifically around the control of buildings and us wanting those buildings to be operated as efficiently as possible. But it is also around the data collection as to what kind of use the building has of its energy supplies and also its water supplies. And finally, there is a strong encouragement here to make sure that condensate coming off air conditioning plant is both handled correctly and is also collected for possible reuse within the building, probably and mainly around irrigation purposes. So just to summarize that small introduction to both the code itself, why we're doing what we're doing, and the way we're going to do it. The Green Building Code has been developed to place a minimum obstacle in the way of any new development. The additional costs have been estimated as highly marginal, very small. The code itself can be used to determine how to apply all articles to particular buildings and ultimately how these articles contribute to the building's ranking or rating. Okay, and finally, those optional ratings are going to become mandatory over time, but very, very slowly. Okay, so what we have in essence is we've 10 mandatory items that have to be complied with in order to achieve the permit issuance. And we've got a further 69 articles that are pretty much optional in nature. And I would suspect if any of the designers on this call at the moment were to go through those 69 optional articles, I think you will find that you already implement the vast majority of them. Okay, so scoring highly on a new building design should be quite a simple process, but that remains to be seen. So now we can take a little look at the various sections that are contained within the Green Building Code itself. The code opens with a section covering the definitions used within the code, and I guess in the construction industry in general. It should come as absolutely no surprise to anyone, and anyone who's involved in the design of buildings will be well familiar with all the terms used therein. the administration section. Competent authority is currently the Ministry of Works, Municipalities and Urban Planning, and they have the final say, obviously, in the issuing of all building permits. The regulations apply to all new buildings from November 2021, as we can see. So extensions, additions are also covered depending on the existing permit rules. So if no permit is required for a building project, then the Green Building Code mandatory items do not apply. So each portion of a multi-use building needs to comply based upon the occupational use. So similar for change of use, the intended new use must comply depending on the actual use itself. Okay, so there are a limited number of buildings where the GBC, especially the mandatory items, do not apply. And for special cases, exemptions may be granted by the competent authority. And these will often happen, at times. At this early stage in the development of buildings in general, it has to be pointed out that the Green Building Code is absolutely not intended to stymie or to cause innovation not to occur, but rather to encourage it. In other words, the green building rating system that is coming will absolutely reward innovation as it is intended or designed into any new building design. So the installation of any new devices, technologies, etc., they are all rewarded and strongly encouraged, particularly if they are coming from the GCC region in particular. It's almost hard for me not to stress sufficiently that it is absolutely the practice currently that the documentation that accompanies the application for a permit absolutely needs to be crystal clear. And this is the responsibility of the applicant. It is not up to anyone in municipalities or any other body who they work with to go find evidence for compliance. Okay, it absolutely needs to be as clear as possible. Okay, you may get permits rejected because that is not sufficiently clear. So there will be a green building declaration form that has to be filled that in essence says that compliance either is in place or it's not in place. It is the responsibility for the applicant of that permit or for that permit to point out where the evidence exists that compliance has been actually achieved. So that green building declaration form must be filled out, stamped and signed as an unconditional commitment that the requirements of the Green Building Code are being met. Declarations will list the articles that have been addressed in the building design and how those articles have been successfully attained with the corresponding evidence. So it is up to the applicant to absolutely prove that the compliance has occurred. Now, in terms of conflicts, I suppose it's fair to say that an extended piece of logic will prevail here, and any conflict between the Green Building Code articles and the existing or future building permit legislation will be dealt with using the most prescriptive prevailing documentation. And in other words, if there's conflict, the most prescriptive standard will apply, would be the easiest way to summarize it. Now, the Bahrain Green Building Rating System, or the GBRS, is going to follow quite quickly on the heels of this, probably in early 2022. The principal aim of this system is to rate or rank the asset, and in other words, the underlying building design, the geometry, materials used, and the Hvac plans used to heat, ventilate, and cool the building. It does not prescribe any operational performance or efficiency, and hence it is obviously possible that a highly rated building can still be very poorly operated or controlled. So for this reason, there's also a planned operational rating that can be applied to both recently occupied buildings after 3 years and existing buildings, and it is going to be an optional system. Okay, now as to whether it remains an optional system forever is anyone's guess at this early stage. But I suspect that some form of operational efficiency will become mandatory over time. So in actually moving on from the administrative section of the Green Building Code, we can see the first of our actual applicable articles to a building design here, contained within the Ecology and Planning section. Okay, so mainly apply to non-residential and non-industrial buildings, as you can see from this table here showing the applicability. These are high-level requirements mainly focused on the site or areas immediately around the planned or designed building to be designed. So this is the first of our mandatory articles here we can see. So we can see Article 22 there is indicated as a mandated item. The other ones, I won't go into too much detail here. I'm hoping they are comparatively clear from a scant read of the Green Building Code, which is contained in Bahrain currently, the latest version of it. So I would advise and encourage all of the designers who are involved in any new design for buildings in Bahrain to have a read of that. I don't think you will be particularly surprised by the inclusion of any of those articles. But as I say, I'm just going to spend a little more time during this session on the mandated articles as opposed to the optional articles or voluntary articles. Okay, so in terms of article number 22, enabled access, this is already covered in the Unified Manual for certain building types, and it is included here to ensure that all disabled folks among us are able to interact with the building in a meaningful way. So our next mandatory item here is Article 26, Urban Heat Island Effect. Again, this is traditionally complied with in Bahrain for the purposes of outdoor comfort. It requires that a particular maximum value of solar reflected index be applied to either steeply sloped or flat surfaces exposed to the sun. It also requires that heat rejection equipment, in other words, if we're outputting warm air to the outside world for any installation greater than 50 kilowatts, that they are exhausted to the outside at a minimum height above the pavement level of 3 meters. Now, this would actually imply a comparatively large installation, and I suspect that that figure of 50 kilowatts will be reducing in future versions and in future years. Okay, it also covers vertical facades, so 75% of external walls with greater or equal to 45% of solar reflective indexes are also covered. So moving quickly on to our next section, which is building vitality, mainly covering the indoor environmental quality of a building. So again, we can see that the majority of these articles in this section are already covered by sections within the Unified Manual of the Bahrain. They are divided into IAQ, internal air quality, and IEQ, internal environmental quality, which obviously includes acoustic quality of indoor surroundings and lighting and so on. So the supply of that indoor air quality is also addressed by ensuring that the ventilation equipment is properly maintained. Any TVOC, the total VOC, particulate matter, CO, carbon monoxide in other words, are also called out for various environments regarding their regular measurement. CO2 or carbon dioxide is added to ensure fresh air levels during occupied hours, particularly in these days of COVID. So this is covered in Article 60. Okay, so this may imply a reduction in energy efficiency where ventilation equipment needs to run for longer hours if we comply with the various recommendations from ASHRAE, the European Centre of Disease Control, the US CDC, etc., etc. Okay, so that equipment may run for longer hours where recirculation of warm air or stale air from within the building is not recommended for a reuse. Okay, so if we look at Article 60 with demand controlled ventilation, tobacco is already covered, called out here and so on. Thermal comfort parameters are already taken from ISO 7730 and ASHRAE standard 55. These are all standards that the designers are very, very well familiar with. Now, any hazardous materials producing high levels of concentration of volatile organic compounds are called out in accordance with the Unified Manual. Ensuring a comfortable work environment with minimum levels of natural daylight and line of sight views with external windows are covered here. And finally, the quality of water in buildings to guard against Legionella, and the same for any water used in water features over a certain size. So you'll notice that in this particular section of internal and external air quality, there are no mandated items, but it is very likely that strong recommendations will be made in the near future with regard to how commercial buildings in particular are ventilated in order to ensure or somehow control the transmissivity of COVID and other important and very dangerous pathogens. So if we move on to our next chapter, or our next section, the resource effectiveness as it specifically applies with energy usage. So we can actually see that energy obviously applies to the vast majority of buildings. They will use energy in some fashion or other, but given the level of energy usage in larger buildings, particularly commercial buildings obviously, the balance here is swayed in the direction of that in terms of the application of these articles specifically to buildings. So we can see a lot of gaps here in the applicability matrix for homes and villas and so on. The vast majority of the application, as I say, occurs with regard to commercial buildings of any form. So we can see here the introductory 5 articles of this particular section in energy usage. We can also see that the figures quoted in these articles, they are a copy of those that are produced by IWA and the Ministry of Housing. They are not considered especially onerous if you consider these numbers on a wide GCC region aspect, but especially not particularly onerous if you consider them in comparison to either the EU or the US. So given that the more stringent numbers apply, if you compare the GBC with any requirements from other ministries or authorities, the EWA limits can keep getting tighter and tighter or more stringent without necessarily affecting the Green Building Code as it's published. We can also see glazing or window U values are shown to be dependent upon the orientation of the glazing. And this makes perfect sense. If you have south, east or west facing glazing, it is better to have those with a higher reflectance value and so on. It's simply the application of common sense. Okay, but it also provides the designers in general with a significant amount of latitude as to how the limits are applied. Thermal bridging is a phenomenon where heat enters or exits a building space through a bridged facade element because of material combinations used in the construction of the multi-layer facade. It should be allowed for when calculating the facade's U values. Air conditioning parameters must be submitted to the competent authority when applying for the permits. This is the only mandated article that is currently here as far as the GBC is concerned. So what these represent is the load calculation figures that are normally presented to EWA in order for EWA to work out the electrical load required for the building. Once you have submitted those figures to EWA and EWA have accepted them, then this article is deemed as being passed. Okay, so that is an important item to remember. So no one from municipalities is going to check those figures. They're simply going to rely on EWA to work out the electrical load that is required for that building, and assuming EWA are happy with that, then this article has been passed. And also remembering it is a mandated article. Okay, so any assumptions obviously you have made in those calculations, EWA I'm sure will examine those assumptions. Air leakage is an important feature, especially in warm and humid climates. So we are limiting that to 10 cubic meters per hour per square meter of building area. Okay, so that is measurable or measured at a differential pressure of 50 pascals between the indoor and outdoor spaces. The overall HVAC equipment efficiency figures that are required are actually listed in Article 59. They are based on comparatively old figures from ASHRAE's numbers back in 2007, which is obviously a long time ago. As a result, it should not pose any significant problem for anyone to comply with those. In actual fact, I would suspect that the vast majority of MEP designers will probably be using equipment that is significantly more efficient. Okay, so these are listed, as I say, in Article 59. Demand control ventilation, while it's not yet mandated, is very important when considering the ventilation requirement for infectious disease transmission due to aerosol-sized particles in the air, especially given the recent evidence that will indicate that COVID can travel quite a long distance. And if the ventilation system within a building is depending upon the internal cooled air, those pathogens or infections can be carried for quite a distance within a building. Okay, so it is very, very important that this is considered. It is likely that this or some form of will be mandated in the near future due to the return to work policy in dealing with COVID. The only mandated item that is listed in this particular slide are electronic ballasts, and I suspect that they are so commonplace at this stage it's almost difficult to find light fittings that haven't got them installed. Okay, but they are mandated because of their electrical efficiency. So internal pipework is often a forgotten partner of HVAC equipment, and leakage can obviously cause major energy losses. So it's important it's complied with, if, however, it is an optional item, as we saw. So Article 70 points to the rising importance of district cooling as a regulated service within Bahrain to all commercial buildings. Its efficiency compared to individual air-cooled or water-cooled chillers is in each building as they're installed is actually very, very high. It's a lot more efficient than having a local air or water-cooled chiller in almost all instances. Article 72 points towards the need of regular maintenance and probably to be included in the operational ratings. And finally, Articles 73 and 74 provide guidance on the recommissioning of buildings. And this is an important aspect because, as we know, the vast majority of buildings simply deteriorate over time and are seldomly revamped and especially recommissioned as far as the plant is concerned. It really only happens when the plant fails. Okay. Again, the recommissioning exercise and the results of that recommissioning exercise will be included in an operational rating framework. So now we come to the three mandated items that are important with regard to the energy section here. So these are indicated here, and as you can see, they center mainly around the metering of energy. So following the age-old adage of if you don't measure it, you can't control it, it is so important that the data is gathered on where energy is going within these commercial buildings, and if it's possible to make that use of energy more efficient. So whole building metering is of course mandatory currently as part of EWA's connection onto the national grid. And also obviously to facilitate EWA's billing policies. But Articles 76 and 77 provide for not only the sub-metering of large plant and HVAC, it also provides for the mandatory storage of such meters' data logs. So as a result, it will be very, very important that those meters are connected to a building management system or a BMS, or as it's indicated here, a central control and monitoring system. Okay, so that connection is very, very important. And the assumption is that that data is probably being collected automatically by the BMS, probably on a 15-minute basis. But those logs have to be kept, and they will be collected specifically by personnel from SEA on a regular basis. So it's very, very important that we start to understand where this energy is going. So I suppose it would not be a green building code unless we were talking as well about the renewable generation of energy on site, particularly in large commercial facilities. So on-site renewables, as we know, come in various forms, but given the successful implementation of the net metering strategy where the export of power is recognised and credited by EWA for later consumption, this allows for the widespread adoption of photovoltaic sites in a climate that is clearly very, very suited to such adoption and use of that particular technology. So three forms are called out in photovoltaic, that is producing electricity, simple outdoor lighting that is capable of storing charge and using it overnight, and also the provision of solar hot water, which might be particularly suited to large-scale accommodation or villas. In any case, the installation of such equipment will, by its very nature, help to offload the grid, particularly at times of high air conditioning usage in the early to mid afternoons. So I suppose it's fair to say that we probably are all aware that while energy is a very, very valuable resource in Bahrain and around the wider GCC region, water is probably of at least equal importance, and the production of sweet water by desalination is a very expensive process. So we're very, very eager to see some controls brought in. There are some controls already in place, but water conservation should apply to occupants of all building types. So water efficient fittings must be used as currently ordered or as currently mandated by Hvac, and these numbers are simply reiterated in the Green Building Code. Both condensate drainage and the recovery of that drained condensate water are both mandated articles within the Green Building Code. The level of drainage, which is likely already done in most modern buildings, and the recovery are dependent upon the building and the plant's size. The recovery and reuse of condensate is mandated for cooling loads greater than or equal to 100 kilowatts, which is a medium-sized building, I guess. At this level, the operator must recover the condensate and to reuse it in a non-human use, such as irrigation, toilet flushing, etc. Now, 100% non-potable water must be used in irrigation systems with a non-return valve fitted. So for buildings greater than 5,000 square meters or cooling loads greater than 350 kilowatts, water metering is required as standard, with the sub-metering of tenants and the data collection from some meters. So all of those sub-meters, they also must provide data automatically to a BMS or some similar system that is collectible on a regular basis by personnel from the SCA. So, and finally, a few other non-mandatory articles. Article 86 here outlines the requirements if a building is either dual plumbed for waste or for grey water reuse. Again, no human contact is allowed for this water. Car washing facilities, commercial ones in particular, are required to recycle 50% of their water, and potable water cannot be used either in heat rejection or cooling tower applications. So again, let me stress, these are voluntary articles. If these are installed, however, they will install sub-metered water meters. Okay. So our final section of the Green Building Code, covering materials and resources, primarily dealing with hazardous materials, the sourcing of accredited or certified timber, and the recycling of waste. It applies to almost all buildings, except where distinction is drawn between commercial and domestic environments. Obviously, the amount of segregation of waste required on a domestic level is probably slightly higher, as it happens, than it is on a commercial building. So we can see this section covers an amount of items here with regard to hazardous use of hazardous materials within buildings. Both the Bahrain Civil Defence and the Unified Manual will control this in terms of materials used for insulation. This is especially important in light of the Grenfell disaster in London, so the particular selection of insulating material is very, very important. Timber used in the construction of new buildings must comply with the minimum standard of 25% from a certified source. The obvious hazardous materials, including lead, heavy metals, asbestos, ozone depleting materials such as CFC or HCFCs, they are obviously already controlled by existing law within Bahrain. A couple of items at the very end there with regard to 5% recycled materials must be used in a new construction. This is something to be insisted upon if you want to pass that voluntary article, where the designers at the time of going out for tender will specifically ask the construction company to comply with this. And finally, for 5% of all materials used must come from the locality taken to mean the GCC region as opposed to Bahrain itself. Okay. Now, over time, those percentages may well increase, and the policy governing the use of materials specifically from Bahrain or the GCC, they actually may become even stronger. Okay. So, and finally, we get to the end of our article list. Construction waste here, 50% must be recycled by following one of these three paths, depending on the materials in question, whether it's concrete, plastics, or timber, for instance. So depending on the building type, the way waste is stored, the way it's sorted, and the way it's handled in terms of the collection must be provided for, and it must be maintained. Okay. And finally, the operational waste management facilities are sized depending upon the building scale, which is a kind of an obvious one. So as I say, like a number of these articles are going to end up in the operational setting in terms of the way the building is rated operationally. They are not things that necessarily apply during the design of the building, other than the asset needs to be designed in a way that allows these operational articles to be followed and complied with. So in other words, if there's no way during the building the building design and construction to segregate waste, then clearly it's probably not going to get segregated during operation. Okay, so it's important the facility itself is included during the design time to allow it happen during the operational phase of the building. So we finally have reached the end of this session, you'll be very glad to hear. Just a few short words with regards to the green building rating system. The development, the scope, the plan in terms of how buildings are going to be rated, that development is complete. And that information will be published, I believe, in the spring of 2022, so comparatively shortly. And also, as indicated throughout this entire session, the pass score, okay, or in order to get your building permit, the rating you have achieved at that point, if you simply just pass those 10 items, is a certified building under the Bahrain Green Building Code. If you wish for a higher rating, you must look to the other voluntary articles that have been explained a moment ago. So it is a multi-point scale, and unlike Hvac and others, it is simply not a pass-fail scheme with regard to each of the individual articles. But while most articles will score a single point, there are a significant number of them that are multi-point scoring, depending on how well you do. For instance, in the energy usage in a building, for instance, we will look at the building on a whole building basis. We will estimate the energy usage of that building, and we will compare that energy use to an equivalent reference building from ASHRAE 90.1 from 2007. So depending on how you score against that, you will get a score between somewhere 1 up to as far as 10 points, where 10 points, the maximum score, represents a 50% increase increase in efficiency. In other words, you're only using half of the amount of power that is estimated for that 2007 ASHRAE 90.1 reference building. Okay, so all will become comparatively clear, as I say, in spring. Also to reiterate that it is indeed the GBC itself is an asset rating system. It is looking at the quality of the construction, the building itself, and its ability to be operated efficiently. But it does not mandate that the building has to be operated efficiently. That will come in a different form of operational rating, where the actual operations are taken into account and the amount of energy that it's actually using will be examined. Okay, so that is a slightly later thing. So the way we're going to score them, in essence, is there will be a certain number of stars, a certain number of points awarded to each building, depending on the quality of that asset and how many of those voluntary articles have been complied with. So as to whether it is pearls or stars or gold, silver, platinum, etc., has yet to be announced. So I won't say a whole lot of it at this point. But as I say, in the very near future, that will become a little bit clearer. And I should also say that depending on how the building is rated, if it's the highest rating, it is capable of being operated very, very efficiently and in a very sustainable manner. And as a result, as we've seen throughout the US, throughout Europe, and throughout Asia, the value of those buildings for sure will increase. They will increase at a faster rate than a building that has a lower rank. So to summarize, the Bahrain Green Building Code has been written into law as of September 2019, Law 214. It will affect all building types from November 2021 onwards. 10 articles have been mandated, and I'm hoping the Green Building Manual is clear on what those 10 mandated article requirements are. So in terms of what can be done today, the mandatory article assessment is required, and assuming a building design passes those mandatory articles, along with all of the other requirements from works, from civil defence, from EWA, Ministry of Housing, etc., assuming it passes all of those, including the Green Building Code mandatory items, then obviously a permit can issue. So I'm hoping you enjoyed that. And we'll be organising some live Q&A sessions to follow up with any questions that you may have. So thank you very much for listening.